Glass fell from the sky. It wasn't raining stones or even diamonds, but millions upon millions of tiny pieces of glass. And it rained for so long that it covered the entire Yucatan Peninsula in a layer 2 meters thick. But where did all this glass come from? Well, to answer that question, we have to go back 66 million years to the end of the Cretaceous period. And while we know that asteroids were the cause of this catastrophe, we didn't know exactly what role they played until recently. We can tell a lot about our world today from looking at rocks. For example, when archaeologists dig up ancient ruins, they look for clues like animal bones or tools left behind by our ancestors. And scientists can date these artifacts to get a better understanding of how our world evolved. This is called relative dating. And it works by comparing younger rocks with older rocks to determine their age. But sometimes we need to be more precise than that. How old is this rock really? To answer that, we can use radiometric dating. This technique allows us to find out the exact age of rocks and fossils down to the year. Radiometric dating works because all rocks contain isotopes, which are different versions of elements. Some isotopes are stable, while others are radioactive and decay over time. By measuring the amount of radioactive isotopes in a sample and knowing how quickly they decay, scientists can calculate exactly how old the sample is. This is how scientists figured out that the asteroid impact that killed the dinosaurs happened about 66 million years ago. They found an asteroid impact site in Mexico called the Chicxulub crater. Scientists drilled into the crater and extracted core samples to analyze. One team used radiometric dating to figure out how old the material in the crater was. Another team found Tektite deposits, which are blobs of melted rock that were thrown into the air during the impact. They analyzed the gases trapped inside the Tektites. And that also gave them a date for the impact. Both teams came up with the same result. 66 million years ago, plus or minus a few thousand years. But there is some debate surrounding this event. Some scientists say it happened over hundreds of thousands of years. Others say it only took a few hours. So how do we know which one is right? Well, it turns out that both could be right, according to a new study published in AGU Advances. The asteroid impact triggered two separate mass extinction events. The first happened over a few hours, and the second happened over tens of thousands of years. So let us take a closer look at what happened to Earth the day an asteroid made the sky rain glass. The asteroid slammed into Earth at 40,000 miles per hour. That's 64,000 kilometers per hour. At first, it left a crater 180 kilometers wide and 11 kilometers deep. And it ejected 400 billion cubic meters of rock and soil. Then the rock and soil started falling back to Earth. Some landed in the crater, but some stayed in the air and rained down on the surface for days. This is what created the layer of glass. But the asteroid also triggered a chain reaction. The impact vaporized a lot of rock, and that vapor caused global wildfires. Plumes of ash reached 37 kilometers up into the atmosphere. These plumes blocked the sun and caused temperatures to plummet. In other words, it got really cold. In fact, it got so cold that glaciers formed in the northern hemisphere, even though this part of the world had been ice-free for 100 million years. It also rained so much that the sea level rose by 200 meters. And most of this water fell on the west coast of North America. And that's not all. The asteroid impact also triggered massive earthquakes, tsunamis, volcanic activity, and a landslide. So you see, the asteroid impact didn't just wipe out the dinosaurs. It changed Earth forever. But most surprisingly of all, it may have only taken a few hours. But how can this be possible? If you watch movies about the end of the dinosaurs, the planet is always covered in dust and ash and it's always dark. But actually, that's not quite right. A new study says that it was light for at least 500 days after the impact. In fact, the sky was filled with colorful displays of light and even beautiful rainbows. And yes, it was still raining glass, but it wasn't raining for hundreds of thousands of years. And if it only rained for a few hours, how could it cover the entire Yucatan Peninsula in a layer 2 meters thick? Well, it didn't rain evenly. Instead, It rained most heavily in the Yucatan Peninsula and parts of North America. The impact also unleashed a gigantic wave of energy. In fact, it would take months for the water to settle down. And that means that the glass rained down over a small area very quickly. So why does everyone think that it took hundreds of thousands of years? Well, there's evidence for that too. After the asteroid impact, there was a long delay before life on Earth began to recover. Plants and animals went extinct. And the ecosystem didn't start recovering until 20,000 years after the impact. But researchers now believe there were two mass extinctions, not one. After the asteroid impact, 75% of marine species and 75% of terrestrial species went extinct. But before this, life on Earth had already been on a decline. Researchers think there was a gradual climatic shift, and that caused some species to die out. So when the asteroid hit, it pushed Earth over the edge, but it wasn't the asteroid itself that killed off the remaining species. It was the chain reaction that followed. So for the first 600 hours, the asteroid was directly responsible for killing off most of the species on Earth. But after that, the survivors died off slowly due to climate change. And that process took 20,000 years. So to answer your original question, the asteroid impact itself only took a few hours, but it would be more accurate to say that the mass extinction took place over 20,000 years. So there's still a lot we don't know about the end of the dinosaurs. And as time goes on, scientists will learn more. Maybe they'll even find evidence of the first mass extinction, the one that happened 20,000 years before the asteroid impact. Right now, that's just a theory. But who knows what the future holds? Now you need to watch What If a Big Asteroid is heading straight for Earth? Or have a look at biggest asteroids that could destroy Earth.